What's the sign-in URL?
They can see it. Do you want me to read it off?
Yeah.
No, I'm not.
Are you fucking kidding me, guys? Come on. Wait,
What?
seriously? What age are I? Oh my gosh. Who put that up? I'm disappointed.
I did not.
They want an RITSEC thing, so they want like signin.ritsec.club.
Oh, because we want to change the domain.
So don't go to signin.ritsec.club. Apparently it's a new form, question mark? And that was not updated.
Oh.
I know how to update.
Okay, hope everyone signed in. If not, please sign in. Thank you. We have some announcements, and I have Jack McKenna up here to announce the first announcement.
Went too fast.
Oh, I went too fast, apparently.
Jack's not first.
Okay, Jack is not first. We have Newman. Sean Newman, please come up. We have a very special announcement.
Everybody, where am I talking? You should be doing this thing. Yeah.
All right, hey, are we good? Hey, everybody. ISTS is coming up in not enough days, and we still have some spots open for teams. So if you're interested, I would definitely consider putting together a team. If you don't know what the heck ISTS is, it's like a red-blue attack-defend competition. We give each team a bunch of different servers and services to defend. You can also attack other teams. We bring in a red team, a bunch of professionals to come attack you guys and hack into your systems. There's a CTF as well. We've got injects challenges. There's King of the Hills for people to fight over servers to take control over them. There's a ton of stuff going on. It's a great way to learn new stuff about security and really get your hands on a lot of different areas all at once. If you've never done it before, I really, really recommend that you consider putting together a team. Teams are of 5 RIT students, 5 students, 5. And once you have your team, you'll need the name, email address, t-shirt size, and any dietary restrictions for each team member. Once you got all that information, head over to blueteam-ists.ritsec.club. Fill out that Google form. If things change, like if somebody joins a team or leaves your team, it's all right. You can go and edit the form submission later. Just shoot me a message and I'll figure it all out on the back end. February 22nd to 24th. Be there or be square.
Wow. A real mic drop.
Hey everyone, welcome to RITSEC. Thank you guys for all coming. I hope you all had a fantastic break. Real quick, how many of you guys are new and this is your first RITSEC ever? Woo! Nice!
This is actually my first RITSEC ever.
Shut the fuck up, Zach. Oh, shit. So, to kick off the new semester. To kick off the new semester, we're going to be having round 2 Halo night. We're going to be up in Sec Lab. This will be February 1st, Friday. Come through, 8 o'clock. We're going to be playing Halo. You don't need to bring anything, but if you want to bring like your game and hardware, that's fine. We're having our first ever hackathon the week February 8th to the 9th. We're going to have 24 hours where you guys can just come through, work on projects. Yeah, we'll be starting it off with forming groups. So you'll work in a group, work on a project. You can either come with a project or come and listen to other people's projects and pick a project, or just show up, meet some people and be like, yeah, let's work on that. And there you go. You don't need a group. You can just show up by yourself and work by yourself. Otherwise, yeah, it'll be fun. We'll have food and drinks provided, so yeah, just come hang out, have fun. You have a question? What time is the event? We're going to be starting an hour after RITSEC, so we'll start at 5 p.m. and it'll go till 5 p.m. the next day.
And it's not a hackathon.
It's a hackathon.
It's not a hackathon. If there's anyone who's not
All
doing
right.
security things, that's not what this is for.
What's the difference between a hackathon and a hackathon?
We're not hopefully going to have hundreds of people show up to this. And this is only about security projects.
All right, cool. You ready, Russ?
Yep. All right, everyone.
You go, buddy.
So now everyone's favorite part of the education portion, the education portion. So without further ado, can I get a drum roll, please? We have the best web student here at RIT presenting today for advanced web. I'd like to welcome up Ohan Philpott.
Thanks, Russ.
Yeah, no worries. How do I? It should be on. You just clip it and we're good to go.
Ohan, is the key to being good at web living at the lodge?
No, it's not
Yeah, I'm really
sleeping.
good at web.
I wonder what it's like that water.
I wouldn't know. Do you guys have a clicker thing, or do I just stand here?
You have to stand here, yeah.
Okay. All right. Hey, everybody. Some of you may know me. As Russ said, my name is Ohan Philpott. I'm a fourth-year computer security student with a minor in web development. If everything goes according to plan, I will be graduating in May. So, fingers crossed, right? As he said, let's get into it. So, what is web? Web is a lot of things, and I can't even come close to telling you everything about it in the hour, 45 minutes that I have. It's been around for longer than I have, and it's been growing probably more than I have. I'm only 6'2". It's huge. So quickly, web is essentially, it's an application that's running somewhere else, and you access it over the internet. And these applications can do many things. They can provide you entertainment, education, some hybrid of them, access to some other service, banking. Online banking is great. You ever deposit a check by taking a picture with your phone instead of having to go to the physical location? That's really convenient. And that's essentially one of the many things that web can do. Primarily, we use HTTP to access these services. And then a little bit more recently, something called WebSockets has come around that I'm not going to talk about. But they're pretty cool. And if you're interested in them, you should look them up. So what is a web page? It's what you see when you access one of these services or applications. Typically, it's composed of 3 components. The HTML, which kind of defines the structure and the content of the page that you're looking at. The words and the basic, header, body, footer type stuff. You have CSS, which is styling. It stands for cascading style sheets. And that will add colors, make things bold. It can do a little bit of animation, but it's really presentation to make things look pretty. And finally, we have JavaScript. And JavaScript is the really interesting part. The only really one of these that we're going to talk any more about today. And it's what provides, it's the language, the client-side programming language. And it's what lets you have dynamic interactions with these web pages. Without JavaScript, everything would pretty much look like Wikipedia. Don't get me wrong, Wikipedia is great, but there's only, things can only be so exciting when all you're doing is basically reading text and maybe updating some of it. So what is JavaScript? As I kind of said, it was released in 1997. Ross, someone's pinging you. And it actually was developed at a hackathon. It was like a day or two, which some people will be like, well, that's why it sucks so much. Everybody seems to hate it, but it's been growing. It's not still that one-day project. It's a high-level interpreted programming language. It can do a lot of great things. It has syntax similar to C, and even though it shares a name, it's not really based on Java at all. And more recently, and by recently, 2009, so I guess that's 10 years ago now, it has transitioned from not only being a client-side programming language, but it has been adapted to run on servers as well. So you may have heard of Node.js, which is a server-side implementation to run this programming language. Here's just a quick little breakdown of things that I kind of made up that seems like
things that make it good and things that make it bad. And the short version of JavaScript, and really this whole presentation and most of security actually, is things that make, what makes things insecure. Most of the time, it's people that don't know what they're doing. So JavaScript, I feel like, gets a bad rap for a bunch of weird stuff and like, maybe cross-site scripting or just being really confusing or you'll see some JavaScript and you'll be like, why does that look like that or why does it even work? And half the time, well, more than half the time, it's some developer that's not really sure what they're doing. And so you may notice I have NPM in both columns here. And that's because NPM is pretty great. That's the package manager and kind of ecosystem that packages come from. And you can get them for either Node.js, as I said, the server side, or client-side packages you can get through there. And it's really great. There's tons and tons of stuff. You can find like pretty much anything that you need. But on the other hand, you can find all kinds of stuff, and people can pretty much just publish whatever they want. So like anything else, installing dependencies that you don't really know what they do, or like some random person publish that's not, Facebook publishes things to NPM, and your cousin could publish something, and one of those is probably a little bit more reputable than the other. So of course, just be careful with what you're installing. So HTTP in one slide, hopefully. Requests and responses. This is the networking protocol for doing web. Requests, obviously, client to server. The main thing that you want to look out for here is it has a method verb. And so I've got 3 of them up here: get, post, put. There's also a handful of others: delete, options, trace, which isn't really used. And so those kind of define, they're a way to tell the web server of what you're trying to do. Gets are used to get information. And that's the default. When you put a URL into your browser and you hit enter, say google.com, your web browser is going to issue what's called a GET request. And it's going to send a request to Google servers and say, I want to get the homepage. And Google will send that back. And you use the other verbs when you want to do other things. So if you want to send like form data, say, to update your user profile, you'll probably be using a post. Servers send back responses to these requests, and instead of the verbs, they send a status code. And that is, they have a bunch of numbers. And so 200 is the one that you want to see. That means successful. OK. That's good. 404, probably familiar with, resource not found. And the different, there's 100s, 200s, 300s, 400s, and 500s. Each of the 100 blocks is kind of a different kind of response. 200s are successful. 300s are some sort of redirect. 400 means that you did something wrong, a client error. So you had a malformed request, or you were looking for something. In the case of 404, you were looking for something that does not exist. Or 403, you're forbidden, you don't have the right credentials to access that thing that you wanted. And 500 are perhaps the most interesting from a security standpoint. It means that something on the server went wrong. So if you sent some sort of form and you had some characters that the server didn't accept and they have bad error handling, and you get back a 500, that probably means that you caused something on the server to go unexpectedly. And so if you're seeing 500 errors, that means that whatever you did either did break something or is on the track to break something, and you may be able to work with that further and actually come out with an actual exploit from that, as opposed to just not working. Servers, Apache Nginx, Node, Flask, they are different ways that web pages can be served and web services can be built. And then quickly, both of them, requests and responses, have headers. I will talk a little bit more about those later. Basically, it's ways to send metadata about your requests and responses. You can put the content type is something that you'll put in there. Authorization and things like cookies are headers. And finally, it's an ASCII protocol, at least HTTP up to version 2. Version 2 is essentially, at a high level, it works the same, but at a low level, it got turned into a binary protocol and a lot of new features that make it a lot more efficient. But the difference between the two protocols isn't really relevant to a security talk, at least what I want to talk about. Zach? 418 error code, for those that don't know, is I'm a teapot. It's when you send a request to a teapot asking it to brew coffee, and it will tell you 418, I am a teapot, I cannot brew coffee. Thanks, Zach. All right, so the same origin policy is a mechanism to make sure that resources are only accessed by things on the same origin. So what is an origin? An origin is a combination of three things, a tuple, if you will, of protocol, port, and host. And so a protocol is typically either HTTP or HTTPS. The port, if it's not specified explicitly in the URL with a colon, is going to be 80 or maybe 443. And the host is the name of the website that you're going to. So google.com, RITSEC, was it club, RIT.edu would all be hosts. So cross-origin content are things that do not share an origin. And so you can, typically you can't read content. And this applies, I should be clear about this, this applies to things that the browser can do. So JavaScript, so if you're making requests with JavaScript, the state origin policy is going to come into play. If you're on the command line, you're using curl, or your browser is making a request, you can go to 2 different websites at the same time in your browser. Like, that's not a problem. But if you're on a website and it wants to use JavaScript to make a request to a different website, it's going to get other resources, you're going to need, it's going to have some rules to follow. And this is kind of the base work, the same origin policy. I believe it's the next slide. Nope, it's not the next slide. It's in like 4 slides. If you do need to do some sort of cross-origin content, you come into something called cross-origin resource sharing, which is coming up very shortly. So this has hopefully been like a basic overview of like web technologies, like kind of quickly going over them. But this is a security club, so we're going to try to talk a little bit more about security-specific stuff. So let's jump over to that. So the Open Web Application Security Project, or as you may have heard of, OWASP, publishes a list of what is called their top 10 web application vulnerabilities, or things to look for when you're evaluating web applications and doing either as a developer or as a penetration tester in this area. So this is the most recent list I could find is from 2017. A lot of work goes into these. There's many drafts as to what should make this list. So here's the 10. I'm not super big on like reading off of slides, but I think this one might be worth it. So we have injection, broken authentication, sensitive data exposure, XML external entities, which is kind of interesting, broken access control, security misconfigurations, cross-site scripting has dropped down to 7. It used to be much higher several years ago. Insecure deserialization. I don't know, what was it, a year and a half ago, if you guys remember, the Equifax breach. That was due to a bug in Apache Struts, which is a Java-based web server. And the exploit that was used in that was a insecure object deserialization. And so you can see, even though it's number 8 on this list, hopefully everybody has heard of that breach, because it was a pretty big deal for US citizens. Number 9, using components with known vulnerabilities. This is what I talked about before. NPM is great. There's tons and tons of packages that you can use. But if you just go installing random ones without really doing any sort of audit, you can run into things that are insecure. You can if you're installing old versions of things because you have like a legacy system and it has a vulnerability, that can be a problem. And then finally, insufficient logging and monitoring. It's always a good idea to know what's going on in your environment, right? And this is not specific to web. And actually, a lot of these aren't like specific to web. Broken authentication, that's a thing that you can see pretty much anywhere. You can see that in your domain. You can see that in like non-web connected applications and also web applications. Same with access control and security misconfigurations. So what is cross-site scripting? I mentioned it a couple times before. Essentially, it's being able to run JavaScript of your choosing on someone else's browser or computer. And so there's kind of three main ways that you're going to do this. There's either reflected, stored, or self. And when someone first told me about self, I was like, no, you're joking. Like, that's not a thing. What are you talking about? But what that means is if you can get somebody to just copy-paste JavaScript into their JavaScript console and push enter, they XSS themselves. And actually, if you want to see a, not really example, but if you want to see a warning of this, the most prominent one I know of is if you go to Facebook and you open up the developer console, there's a big red warning. It's like, stop. Do not paste anything in here. If someone told you you can like get free money or like hack someone's account by doing this, they're tricking you. I thought that was pretty interesting. So if you want to check that out, facebook.com, open up developer tools, your browser of choice, and it should be right there. Reflected is essentially if there's a page that has a parameter, a get parameter, say. So you have you make a request and you want to go to page 10 of some blog or something. You'll send a request and you're going to say, I want page 10. And if that page is written poorly, it will take that 10 from your request and just put it on the page, like in the bottom right. It's like you're on page 10 right there. So if you say, can control that, and it's not getting filtered or any validation is done on that, you can take that 10, and instead of putting a 10, you can put a JavaScript tag. And that JavaScript will just get echoed into the page, and you can run whatever you want. So the way that this works is if you craft a URL with some sort of payload, instead of, like, say, a page number, you put, send me your cookie. I'm just going to say that, but you can write JavaScript to do that. Then you can, if you get someone to click on that link with your parameters already set there, then they'll go to that page, and then that script will get injected when they see it, and their browser will run it and do whatever you told it to do. And then, say, send you their cookie for that site, which will let you log in as them, or really anything that you wanted to do that's a viable JavaScript exploit. Stored XSS is essentially the same thing in that you are running some sort of JavaScript that you want on their browser. The difference is with stored, you don't need to get anybody to really click on anything. It will be stored in that website. So say the site's doing something, and you set your username to a malicious script. And every time that you go to a page that your username is on, instead of it saying Ohan, it says script alert 1, say. And the website's not doing any sanitization between the database and displaying whatever it's reading out of it. So if you can store a JavaScript payload in the database, anytime anybody goes to a page that has what would be my name on it, say it's a forum, and I made a comment, instead of, they don't have to click on anything extra, they're just going about the site normally, and as soon as my name would be there, this script gets executed. So that's kind of XSS kind of broadly. Important to note that it does require user interaction. At the very least, they have to load a page. With stored, they have to load a page that has been infected. The other two require a little bit more involvement. They have to click a link somehow or paste something into their console. But this is attacking users and their browser. It's important to think about there's a lot of different exploits and attacks that I'm going to talk about, and what is kind of the goal of each one of them. So this one, it's primarily targeting like physical users and their browser, and usually a specific site. So what's one of the ways to protect against this? Obviously, serialization and validation of inputs, that's kind of key for everything. Don't just let stuff get echoed out. Don't just trust your database, let whatever people are putting in there. But another thing that you can do is use something called a content security policy. And I believe this top bullet was just copy-pasted from OWASP, or maybe Mozilla. Essentially, you set up a whitelist of places where you want to allow scripts or resources to be run from, that you say are OK to run. So you can either set this up in an HTTP header on the when the web server, you in this case being whoever runs a web server. So you send back in a header saying, I want to allow scripts from XYZ location, or you can put it right in the meta tag, which is an HTML tag, and say, this is where I'm allowing things to run from. And the browser will read these and say, OK, so if a script shows up, say through reflection, it's like, OK, this is not allowed. You can't run a script. So one of the things you can do is specify hashes of script. If you need to have inline scripts, when you're writing your HTML, you can have a script tag, and you can write any sort of JavaScript that you want, and it will work. But if you can say with content security policy, if you know that you need to have scripts inline like that, what you can do is you can actually generate a hash of them and put that as one of the valid sources. So if a script gets modified or another one gets loaded, then the hash will be different, and that script won't run. So if something comes in via reflection, say, then either the hash will be missing, or it'll modify the one that's already there, and it won't work. And your browser will say, OK, this is not valid, and I'm not going to run it. And it's not, you can use CSP for more than just scripts. It can also work for images and styles, basically any kind of resource that you'd be using. But perhaps the most interestingly of them is scripts. Anyone that takes Time's web security class, you talk about this for at least a week and do a pretty big homework on it. It's pretty cool. It actually has a built-in reporting system. So your browser can actually report. You can set up kind of an auditing URL in your browser, or anyone's browser that goes to that site that has a CSP violation can actually send a report to you, the web server owner, and say, like, there was a violation on this day, and like, this is what happened, which is pretty cool to see. If you're, like we talked about, monitoring is really important. So, as I thought this was earlier, but cross-origin resource sharing is another set of headers to allow to basically tell your browser that you are allowed to do more than the very basic same origin stuff. And this is important because a lot of times sites they'll want to load resources from things like CDNs, depending where they are, content delivery networks, which is a way to, like if you've ever heard of Cloudflare or Akamai, ways to distribute your resources and your services so that they have good availability no matter where in the world that you are. And so if you're hosting, say, your JavaScript files on the CDN, it's going to be a different origin than your site. So if your site is bob.com and the scripts are all getting hosted on alice.com, those origins are different, the hosts are different, and so the browser is not going to be able to load them. But if you have set up your cores properly, you have to do this on the service that is hosting the resources that you want to receive. So whoever is hosting those scripts needs to set this up to say, yes, you are allowed to get these from somewhere else. And so there's simple requests or pre-flight required requests. And these, the simple ones don't have to do a pre-flight. I guess that's kind of obvious. And the pre-flight requests are done kind of transparently by your browser, and it sends an options request, which is just another type of HTTP request, like a GET or a POST. This one's called options. And options, what it's typically used for is it asks the web server what are the options available for this endpoint that I want. So you usually get back a list of HTTP verbs. So like this endpoint accepts GET requests and POST requests, or something like that. And so your browser will transparently send this options request with a list of headers. Basically, these are the response headers, but the request headers are very, very similar. They're basically asked to, they basically ask if they can request. So instead of, so allow origin, you say, can I use, this is my origin, is this origin allowed to get this resource? Am I allowed to use these methods? Am I allowed to grab these headers? Stuff like that. And if the server is configured properly and you are allowed to, it'll send these ones back and say, yes, that's allowed. Yes, this is allowed. These are the headers that you are allowed to see from this endpoint. This is how long you're allowed to do it for with max age. And sometimes you need to allow credentials. And that's a setting that you need to set both on the server and in the JavaScript that's making these requests. There's a property of the XML HTTP request, which is the name of the JavaScript object that does AJAX requests for you when you want to use JavaScript to make requests to other sites or your own site. You use that object, and that's a setting that you need to set, allow credentials. And if any of these things, so if you say I want to use credentials and the server is not configured to use credentials, that pre-flight's going to fail and this whole request is going to fail. Same with if anything else doesn't really match. You say, I'm this origin, can this origin request? And it's like, no. The whole thing fails, and you'll see in your console that there was a CORS error and that for whatever reason, the request has been denied. And you can't do this. You can't get this request that you want. And again, this is all for the browser and like JavaScript requests. So you, if you're using curl or if you're just going to 2 different tabs, this shouldn't apply. But if you're doing something on a specific web page, this is a security concern that you can set up to protect against which resources will get loaded. So cross-site request forgery. I'm throwing this one in here because this one, if you get, it's important, and it's also a common interview question. So if you go into something with application security or web security, there's a good chance that they'll ask you about this. So what it is it's being able to trick somebody's web browser into making a request to another site. And so how does that work? Well, actually, how it works, I have a diagram on the next slide that hopefully is big enough. And you need 4 things to happen. The target site, site B, we're going to say that's your bank. B, bank, kind of makes sense. It has to be vulnerable to cross-site request forgery, basically not have any validations built into its system. And it must have a URL that has some sort of side effects. So side effects can include transferring money between accounts, if we're talking about a bank, changing your username or password, making a post, I suppose. That's not as exciting as giving yourself money, but that could be another thing. And so kind of hand in hand with that URL with side effects, if it's like a form or something, the attacker needs to know all the values that form expects. So if it's transferring money, you need to have a destination account and an amount. So if the attacker only knows that they want to send themselves $10,000, but they don't know what their account number is, that's not going to be very helpful. So they need to know both. And finally, the victim must visit a malicious site, we're calling it site A here, while they're logged into site B or their bank. So let's have a look at a diagram. All right, this doesn't look like it's too small. OK, so step 1, you sign into your bank. You're signed in, you have a valid cookie. And then you somehow, for whatever reason, you go to a malicious site, site A, and that site contains some sort of CSRF code. It can be a form with some JavaScript that automatically submits it. It can even be like an image. Images make requests by default. They just issue a GET. So if your bank for some reason is using a GET request to send money, you could do it with an image. In this example, it's doing it with a form and a little bit of JavaScript to automatically submit that form. So you go to this page. Hopefully you can see it. It's saying there's a form here to make a request to your bank.transfer/transfer with a recipient and a value. And once you go there, the JavaScript on that page will automatically submit that form. Your browser will send the request. And since you're already logged in to your bank, the browser will automatically add your authentication to the request that it's making. And that will go through to your bank's website. And it will be, well, it will be, since you're already logged in and they don't have any protections, it'll be accepted, and that money will get transferred from your account to my account. And I'm happy about it. So how do you stop this? That doesn't seem very good. You want to keep track of your money. The easiest check and actually fairly robust one is to check the origin headers. And the origin header and the refer header also, you can also use that one, are they are restricted headers. And what that means is that JavaScript, when JavaScript sends requests, or can't modify them. They're added by the browser, and there's nothing you can do to modify them as on the client side. And so your browser is the one making this request, right? The form was there, and the browser triggered that JavaScript, and it ran, it sent that request for you. And so the browser is going to tack on an origin header. And if the origin that a request is coming from, in the example case, it would be attacker.com, site A, that does not match mybank.com. Those are not the same. So the request is coming from a different origin. That means that there's likely something malicious going on, and we should not accept that request. The other thing that you can do, and you may have heard of a CSRF token. And essentially what that is it's an extra bit of data that's added to requests, usually as a hidden field in a form. And it will, it's a way for the server to, the bank server to validate that the request is coming and that all the values are actually known. Remember how the attacker needs to know all the values. So if you are only requiring a destination account and an amount of money, that's easy to know. But if there's a random value that needs to get submitted as well that changes every time you load the form, then there's no way to have prior knowledge about that. So there's kind of two kinds of tokens that you can use. You can have one where you submit it in the cookie and then also in the request, and it can check that those are the same. The reason that this works is you can't modify cookies for other sites in JavaScript. Even though the cookie got attached to the request by the browser, there's no way to modify cookies that aren't your own. So attacker.com and mybank.com are completely different sites, so they have no way to access each other's cookies. So this works. The other way, which is a little bit more complicated, but also totally works, is a synchronization token. And this is a little bit harder because it requires your backend, so the bank in this case, to keep track of all the tokens that it's issued and generate random new ones for every form that it is, for every user and form that they want to submit. Also, if your bank site has cross-site scripting vulnerabilities, this is, you can grab these tokens. And so if you are vulnerable to both cross-site request forgery and cross-site scripting, you're in big trouble.
You should switch banks.
Yeah, you should probably switch banks. Thank you, Joe. So this was number 1 on the OS list, injections. And it's kind of a broad term, so I just threw 4 of them up here. So you've probably heard of SQL injection. It's probably the most famous of the injections. And this is, what does it do? It gives you access to a backend database. You can actually also do NoSQL injections, which are NoSQL databases. It's a little bit more tricky, but you still can sometimes do it. There's something called command injection. This allows you to run essentially arbitrary commands on the backend server. And from there, essentially you can get a shell on the server, and anything you can do with that shell, well, it's up to your imagination pretty much. And finally, server-side request forgery. This allows you to access internal services. So say that their web server is running, and that's the only thing that's exposed to the internet, but they're also running their mail server on that network. You can potentially have access to their mail server with something like server-side request forgery. So SQL injection, I'm just going to kind of go through these sort of quickly with an example. So your web server is just running raw SQL queries. Select star from users, where user ID equals some user ID that they get from a GET request. Say this is a basic search function. If you search for, in this case, if you search for double quote or 1 = 1, semicolon, pound, what that does is it generates this bottom query that the web server will run. So it runs select star from users where user ID is blank or 1 equals 1. So user ID is blank, there's probably nobody with no user ID. But since it's an or, 1 equals 1 is always true. So it's going to select everything in the database. And that's kind of a basic example of SQL injection. Ways to protect against this. The one that I like, obviously, sanitization and input validation are things that you can do. Another way to protect against stuff like this is using something called a, what is it called? An object relational database something. Basically, there's packages that you can use that will map the database structure to your whatever language that your backend is running in. So say you're running Python, then you would use something called SQL Alchemy. And it would turn your database table, if you're familiar with SQL, you've got your tables, into a Python class. And then your interactions with that class are then, if the database interactions with your program and your interactions with the data are abstracted, and so you manipulate a Python class, and then that library will manipulate the database accordingly. You don't ever have to run raw queries like this. Command injection is running arbitrary commands. So this is kind of an extreme example, but it sort of gets the point across. Sometimes people think it's a good idea to have their web servers run shell commands for whatever reason. So in this example that I made up, it's catting an HTML file with the page number that we asked it to do. And so this is like a PHP example. So shell exec is how you run a shell command. And then string concatenation is done with a dot and a space. So it's basically cat, space, and then whatever the page number was from your GET request, and then .html. So if you sent one, if you said I want page number 1, it would do cat, it would cat 1.html. Is how that's intended to work. What you could do is send a 1, and then you could do a semicolon. And in bash, that indicates that that command is done. You want to start a new one. And you could do cat se password, and then maybe another semicolon just to be safe. And the resulting command that gets run is cat1. That's probably just going to throw an error, but that's OK. And then you're going to cat se password, and that's pretty exciting. And then you're going to run a .html, which probably isn't command either, but who cares? You could do something similar with SQL. You could like put comments in here if you wanted to, or like error redirection if you want to get fancy with it. But this is just a basic example of sometimes you can run commands. The injections don't always have to be to a database. They can be to the underlying web server itself. Sometimes it's not directly to a shell. You can inject into whatever programming language is running. So one you might see is a Python eval for some reason. And so if you can start executing, maybe you can't run bash commands, but you can run Python. And it's pretty trivial to get from running Python to getting a shell for yourself. So essentially, it's the same thing, but with extra steps. Server-side request forgery. I wanted to throw this in here because I had it on the injection slide. I've never been very good at explaining it, but there's a blog post there that I highly recommend that you read. It was for a bug bounty in GitHub Enterprise, and the combination of the bugs that he found using primarily server-side request forgery, the combination of all the bugs and the blog post that he wrote, which is really good, netted him $12,500. So definitely worth a read if you have, I don't know, 15 minutes. The short version is you trick a web server into sending a request to another server on its, well, usually on its own network that's like not connected to the internet. But I guess it doesn't have to be. Having the web server send a request for you instead of tricking someone's browser to send a request for you. XML internal entity, external entity. I threw this in here because it's on the OWASP list, and a couple people on the workplace asked for it. So here we are. I'm going to try to tell you about it a little bit. So when there's an XML parser, and it's overly permissive in what it allows you to ask for. you can ask for external resources, and these can, depending on what kind of resource you ask for, it has a variety of side effects. You can get data exfiltration, right, like reading local files. You can ask for things that you shouldn't be able to ask for that will potentially perform a denial of service for whatever server that is. Apparently, you can do port scanning. I didn't really read into how that part works. And SSRF. Actually, I think I do know how that would work. But the easiest example is local file disclosure. So you can essentially ask for an entity, and you can declare it with like a file URL and say, OK, like I'm looking for this resource. It's at file://etc/password. And if the parser is misconfigured, or it will let you read this, and there you go. There's a lot more. OWASP has a big page about this you can read about. That's pretty good if you're interested more in this type of vulnerability. So we're almost done. Some random tidbits. Web security is just like any other application security. A lot of the same concerns, like we saw from the OWASP list, aren't necessarily specific to web. Some of them definitely were, but things like security misconfigurations and bad authentication are not exclusive to web. The other thing is reconnaissance. Whenever you're doing some sort of evaluation, as much information as you can gather about what you're evaluating or attacking is going to help you out. If you can find server versions, is it running on Linux? Is it Apache? Is it Nginx? If it's Python, what version of Python? Is it Python 2.7? Is it Python 3? What dependencies are they using? Are they running WordPress? Are they running this WordPress extension? Are they running PHP 5 instead of PHP 7? There's all kinds of things. As much information as you can have, the more information you can use to figure out where things might go wrong. If you get server versions or extension versions, you can look those up and say, oh, is there a vulnerability in this version, as opposed to the newest version. Maybe it's patched, but if they're running one they haven't updated in a while, that one is vulnerable. That can help you out. Anything that has to deal with user input is going to be dangerous. Any sort of processing, basically never trust the user, and by extension, never trust the client. This is a little bit more for programming, if you're doing any sort of web development, but you can do form validation or something on the client side to make it easy for them so you don't have to send requests, but don't just trust if you do that validation with JavaScript. When it gets to the back end, do the validation again. It's a little bit more work, but in the long run, it's going to pay off. And again, with many areas of security, there's lots of tools that can help you, but they're not going to do your job for you. If they could do that, you wouldn't have that job. So there are many tools that can help you. Look into them, see which ones might be helpful for what you're specifically doing, but they're going to help you. So learn how to use them to make your job easier, not to do it for you. And I've got the Chrome developer tools in here, and I have a slide just for that, because it's really helpful. It has a lot of features. You can inspect pages. This is good for development, and also to see like there's something weird going on a page. You might be able to see it if they've left comments in their HTML or they've commented out sections. That can be helpful. Comments. If you're doing application testing from the client side, you can read HTML comments. If you have access to server source code or any kind of source code for an application, reading comments, searching for things like to do or like bug, those can be helpful in discovering where things may be going wrong. The JavaScript console is obviously huge. You can see things like CSP errors, CORS errors. You can also see if there's bugs in the JavaScript, if things are breaking. It'll show up there. You can expect requests. There's a basic requests inspector in here in the Chrome tools. You can even right-click on them and say like copy as curl or copy. There's a couple other things that you can copy it as. So if you want to run it again from the command line or modify something and run it like that, that's an easy way to do it. You can view TLS certificates. You can view cookies. Tons of other helpful stuff that you can do in the dev tools. And finally, here's some resources. This is not an exhaustive list. And basically, nothing that I said today is like some secret knowledge that only I know about. I found all of it by going to these sites and a couple others and compiling things that I thought would be useful and putting them in some slides and talking to you about them for 45 minutes. If there's something that you thought was interesting that I didn't go into enough depth about, You can talk to me about it, or you can look it up, and you can probably find tens of pages, maybe even hundreds if it's something really popular, to learn more about that thing. Some other demos I know, talks come up here and people talk about like maybe reversing. Those usually go over my head anyway, but I'm like, I don't even know if I can try to Google for this and I can't find it. That's not the case with web. There's tons and tons of resources to help you out. That's pretty much all I have. I actually do have to go to class now. Thanks for listening to me. Good luck with the demos.